Good morning, one and all. Today I'm going to deal with the topic data communication. So these are the textbook that is preferred for data communication, that is for Rosan BA, data communication and networking, and also William Stallings, data and computer communications. So we move on to the definition of data communication. Data communication simply means exchange of information between two devices, and the exchange of information should be through a transmission medium, and it should be a wired or wireless. That is, it simply means data communication simply means we are communicating the data, or we are sharing the data between two devices. And the main fundamental characteristics of the effective data communication is delivery, accuracy, timeliness, and jitter. That is, message should be correctly delivered and it should be accurate. There should not be any changes in the message we are sending, and it should be timely delivered, and there should not be any delay in the message we are sending. So that is the main fundamental characteristics, that is delivery, accuracy, timeliness, and jitter. So that's about the definition and the fundamental characteristics of data communication. Next we move on to the what are the components of the data communication. So from the figure itself, it is very clear that the main components are sender, receiver, the message, and the message should be in a transmission medium, and there should be a protocol, there should be a rule for the sender and receiver. So we will see each one by one in detail. First, we see the message, and the message is simply the information we are sending from one device to another. It should be audio, video, text, numbers, anything. That is the message. And the sender means the device that are sending the data. That is the sender. And a receiver, it's a device that is receive the message. So, or receive the data. Then about the transmission medium. The transmission medium is the physical path that is a message travel from sender to receiver, and the example of the transmission medium is twisted pair cable, coaxial cable, fiber optic cable, and radio waves. And a protocol is set of rules that govern the data communication, and it's simply the agreement between the sender and the receiver. And that's about the components. So the main components are sender, receiver, the transmission medium, message, and protocols. Next we move on to the data flow. That is, communication between the two devices can be either simplex, it should be unidirectional, bidirectional, omnidirectional, etc. etc. So between the communication can be divided into simplex mode, half duplex mode, full duplex mode. In simplex mode, the direction of the data is unidirectional. That is, only one of the two devices can send the data, and the other can only receive. For the example, for the simplex mode is keyboard and monitor. That is, it's only a one-way communication. And the example for this keyboard and monitor. And in half duplex station, both the devices can send and receive, but only one at a time. In simplex, only one data can send, not the other data. All the other duty of the other data, device is to receive only. Whereas in this case, both the two devices can send and receive, but only one at a time they can send or they can receive. So that's half duplex mode. And the example for this walkie-talkie, in full duplex mode, both the station can transmit and receive the data simultaneously, but that at a time both can send and receive. The main example for this is telephone network. Simply have a telephone network, that is, at a time both the persons can talk. So that's simplex, half duplex, and full duplex. And this is a comparison of simplex and half duplex. And when comparing this, the full duplex has the better performance when comparing the simplex and half duplex. And in simplex, the mode of transmission is unidirectional, that is, it's a one-way communication. Whereas in half duplex, it's a two-way communication, but one at a time can send the data. And full duplex mode transmission is two-way communication of data all the time. Then in simplex, the sender can send the data but can't receive, whereas in half duplex, both sender can receive the data but only one at a time. In this, both can send and receive the data simultaneously, and it has less performance. Half duplex is little more performance when compared to simplex, whereas it provides less performance when compared to full duplex, and full duplex provide more performance. And the examples are keyboard, monitor, and half duplex are walkie-talkie, and full duplex is telephone. Next, we move on to the periodic analog signals. We can say that signal can be, or the information we are sending can be signals, data, anything. So the signals can be analog or digital. Analog signal means it has many levels of intensity over a period of time. That is, when it is moving from one period to another period, it travels through many infinite values, whereas in digital signal it passes only through a limited values. In the figure itself we can say that when it moves from one point to another, it passes through infinite number of values, whereas in this it passes through a limited number of values. In this case, analog signal, there is no limit. It can be passed over infinite number of values, whereas in digital signal it should be a limited number of values, and it should be usually expressed as 1 and 0 binary. Then next we discuss about the periodic and non-periodic signal. And periodic signal completes a pattern within a measured time frame, that is called a period, and it's repeat the pattern over subsequent identical period. That is, periodic signal should have a pattern. That is, it have a pattern at 1 second, then it should repeat the pattern for the next 1 second. So it is a repetition. So it should form a pattern and it should be repeated after each period. And the completion of one full pattern is called a cycle. And whereas when we compare to non-periodic, it does not exhibit a pattern. It does not repeat over time. That is the difference between periodic and unperiodic signal. And a periodic analog signal can be again classified into simple and composite. And a simple periodic analog signal cannot be composed into simple signal. The example for this sine wave, it cannot be composed into further simple signals. Whereas in composite periodic signal, it composed of multiple sine waves and it composed of multiple signals. In simple, it cannot be decomposed into simple signals, and its example is sine wave. Whereas a composite signal, it consists of multiple sine waves. That's the difference between a simple periodic analog signal and composite periodic analog signal. And this is the sine wave. The most fundamental form of periodic signal is a periodic analog signal. That is, it will repeat a pattern over one period. The pattern is repeating. It form a pattern. That is, it's a continuous flow. That is sine wave. Then a sine wave can be represented by three parameters: peak amplitude, frequency, and phase. And the peak amplitude is the absolute value of its highest intensity proportional to energy it carries. This is the peak highest intensity the wave carries. This is the signal with high peak amplitude and a signal with low peak amplitude. This is the low peak amplitude. Then next is the period and frequency. Period refers to the amount of time the signal needs to complete one signal, and frequency refers to the number of periods in 1 second. And period and frequency are inverse of each other. F equal to 1 by t and t equal to 1 by f, and frequency is always represented in hertz. Then we move on to the phase. The phase, another parameter for representing the sine wave. The time phase or the phase shift describes the position of waveframe relative to the zero. Time phase, or we can say the phase shift. It can be either phase or phase shift. It's both the same, and it is the position of the waveform. That is, the waveform changing its position with relative to zero. That is, the wave can be shifted backward or forward along the time axis. That is the phase shift. So that is the phase, and it indicates the status of the cycle. Then next, the wavelength. Wavelength is another characteristic of a signal traveling through a transmission medium. Wavelength binds the period or the frequency of simple sine wave to the propagation speed of the medium. And the wavelength is simply means a distance a signal can travel in one period. In the figure, this is the from this to this. This is a one period. So the distance the signal can travel, or we can say from this to this, the distance the signal can travel in one period is simply the wavelength. And that is the equation for wavelength. That is, wavelength equal to propagation speed into period, or we can say that propagation speed by frequency. The wavelength is represented by lambda. Lambda equal to c by f. C is the propagation speed and f is the frequency. Next, the time and frequency domain. So in order to show the amplitude and frequency, we can use frequency domain plot. So and it should be more convenient, and it should be very clear the values in the frequency domain. In the figure itself, we can say that in the time domain plot, it is very difficult to understand when compared to frequency. Frequency domain is very easily understanding. So frequency domain plot is considered with only peak value and the frequency. It considers only the peak value and the frequency. In the time domain, amplitude and frequency, everything is concerned. So that is about the time, frequency domain and time domain. Then the composite signal. So a composite signal, as I said earlier, that it composed of multiple sine waves, and a single frequency sine wave is not useful for data communication. So you're using composite signal, that is, it made up of a multiple sine waves, and in a composite signal there are multiple sine waves, so each sine wave should be different frequency, different amplitude and different phases. These are the frequency, amplitude and phase are the parameters of a sine wave. So composite signal consists of different types of sine wave, multiple sine waves. So each sine wave should be different frequency, different amplitude and different phase. And the bandwidth simply means the range of frequency, that is in a signal, in a composite signal, that is it's simply a difference between the it's simply difference between the frequencies of the composite signal. That is, as I said earlier, that the composite signal consists of multiple frequencies, multiple sine waves. Then each multiple sine wave has its own different frequency, different amplitude and different phase. So the bandwidth simply means that difference in the frequencies. For example, if a signal contain bandwidth between 1000 and 5000, its bandwidth is 5000 minus 1000, or we can say that 4000 is the bandwidth of that sine waves or that signals. So that's all for the today. Hope you all understand the topic data communication. Thank you.